Welcome to this presentation on the basics of optical communication. In this session, we'll explore key concepts, components, and exciting applications of this fascinating technology. Optical communication involves the transmission of data using light waves through optical fibers or free space mediums. Its key features include high-speed data transfer, long-distance communication, and immunity to electromagnetic interference. Why optical communication? Optical communication offers several advantages, including high bandwidth, low attenuation, and immunity to electromagnetic interference, making it both secure and lightweight. From the internet backbone to telecommunications, healthcare, and military communication, optical communication plays a crucial role in numerous applications. Basics of light propagation in optical fibers. Total internal reflection is the key mechanism that enables light to stay confined within the fiber core. The numerical aperture determines the fiber's light-gathering ability. However, losses due to attenuation and dispersion, such as modal and chromatic dispersion, can affect the signal. Components of optical communication systems. These systems include transmitters that convert electrical signals into optical ones, optical fibers as the transmission mediums, and receivers that convert the signals back to electrical form. To extend transmission distances, amplifiers like EDFAs are used to boost the signal strength. Wavelengths in optical communication. Commonly used wavelengths include 850 nanometers for short distances and 1310 and 1550 nanometers for long distances. The 1550 nanometer wavelength is favored for its lowest attenuation and compatibility with amplifiers. Multiplexing techniques. Wavelength division multiplexing, or WDM, allows multiple signals to use different wavelengths. Dense WDM is used for long-haul networks, while coarse WDM is applied in metro networks. Time division multiplexing, or TDM, separates streams into time slots. Free space optical communication. This involves transmitting light through free space rather than fibers. It's used in satellite communication and wireless point-to-point links but is challenged by weather conditions like fog and rain. Applications of optical communication. Optical communication powers high-speed internet backbones, telecommunications, undersea cables for global connectivity, and advanced uses in healthcare and defense for secure channels. Challenges in optical communication. Challenges include the high cost of installation, fragility of fibers, nonlinear effects like Raman scattering, and sensitivity to environmental factors such as temperature. Optical communication offers unparalleled speed and security for data transfer. While challenges exist, advancements like 5G integration and enhanced networks are paving the way for the future. Thanks for watching, and we'll connect with another informative video.